This is the video for lesson 6.3, and if you would please pause for just a moment, write in the learning target. For this lesson, the learning target is I can use the AA, that's angle, angle, similarity, postulate. So that's our only vocabulary. If you take a look here, angle, angle, similarity, postulate is our only vocabulary, and it says if two angles of one triangle are congruent to two angles of another triangle, then the two triangles are similar. It's really important that you pay attention to the idea that we're talking about similar triangles, not congruent triangles. Remember, the symbol for similarity is just the little squiggle. Okay, the little squiggle. And so if you're asked to write a similarity statement, you want to make sure that you're writing, the symbol for triangle, the name of the triangle, a similarity symbol, another triangle, and then the name of the other triangle. So let's go ahead and take a look at our first example. It says that we want to use the angle-angle similarity postulate, and what we're going to do is state whether these two triangles are similar. And we don't want to say that they're congruent. It's just that we're trying to find out if they're even similar. If they have two angles that are congruent, then they are similar. So if we look at the triangles, we see that there's a 90-degree angle here, a 38-degree angle there, a 90-degree angle here, and a 52-degree angle. Well, we do need to find out what the measure of angle F is, and we do need to find out what the measure of angle A is. And then we can make a determination if these two triangles are similar, if they have two angles that are the same. So 90 plus 38 is 128. And if I subtract that from 180, I get 52. And therefore, there are two angles that are the same. These two and these two. I guess I could check and see what the measure of angle F is, but it should be 38 because if I add 52, so either way I did chose to do this, it would be coming up with the same answer. So now we can see that the two triangles have the same measures, and so we can make our similarity statement because it does say if they are similar, then we need to write a similarity statement. So triangle ABC is similar to triangle, let's say DEF. And we also need to explain, so basically what we need to say here is at least two angles are congruent, which means the triangles are similar. Okay, so they don't have to be the exact same. In this case they are because we can see that the angles are all the same measure in each triangle, but at least two of them have to be the same so that they can be similar triangles. Alright, and we're going to kind of extend this idea into example 2. We want to show that the triangles are similar, show that the two triangles are similar, and then also we want to explain. So I'm just going to write that part in there. Basically, you're going to just support your idea by saying that there are at least two angles congruent. And I'd like you to do that also with the on your own practice problems. So if you would please put an explanation with each one of your answers there. So for example number 2, part A, it says, show that the two triangles are similar, and we're talking about triangles TUV and triangle HJK. So notice that we have an obtuse angle here in each of them, but we need one more angle to be congruent between the two of them. But if I look here, I see that this angle and this angle are congruent, and this angle and this angle are congruent. And how do I know that? Well, the legs of isosceles triangles indicate that the triangle is isosceles, and therefore the base angles are congruent. So if I take 180 and subtract 115, and each triangle has a 115 in it, doesn't it? So we're going to use that. We have 65 degrees left over. So angle U is going to be 32.5, and angle V is going to be 32.5, and so is angle J and angle K. So it looks to me like these two triangles are similar. Notice that triangle TUV is much smaller, but they have two angles congruent, therefore they are similar. So we need to write our statement. Triangle UTV is similar to triangle JHK, and the reason for that is each triangle has two congruent angles. And let's move on to problem B. We need to prove that triangle LMN and triangle PQN are similar. So if we notice at the very bottom, we see that angle N is actually going to be congruent in both of those triangles because it's the exact same angle. So we could call that a reflexive angle, right? We know that that's congruent to itself. And then if we look at the parallel markings right here, we're noticing then that we have some corresponding angles that are congruent. So I'm going to say that angle L and angle QPN are corresponding angles. And I'm also going to notice then that angle PQN and angle M are congruent because they're corresponding as well. And therefore we can see that we have at least two angles in each triangle that are congruent. So one other thing I want to add is that angle M and angle PQN are corresponding angles. And we do have at least two angles in each triangle that are congruent. So I'm going to write this out. And therefore, remember our three dots, therefore, triangle LMN is similar to triangle PQN. So in your assignment, you're going to also have to make those similarity statements. So just remember, a similarity statement looks like this. Okay, that's why we're practicing them here in our notes so that when you get the direction to write a similarity statement, you're doing that properly. All right, so please practice on your own the 4 problems at the bottom of the page here. And I just want to give you a hint. As you're writing these similarity statements, make sure that there are at least 2 angles that are congruent. You do want to explain. Okay, remember you're explaining. And I'm going to give you a hint that there is one of these 4 that are not going to be similar. Okay, so one is not, you're not going to have a way to show that they are similar. Okay, let's go to the back of our paper. All right, here on the back we have example 3 where it says use indirect measurement. And we've already done some problems like this in previous assignments, so I just want to go through this quickly and then you're going to do the practice problems down at the bottom of the page. A building casts a shadow that is 78 feet long, and at the same time a nearby signpost that is 5 feet tall casts a shadow that is 39 inches long. How tall is the building? Well, they've given us 2 different units of measure. So we have feet in 2 of the measurements, and then we have inches in another measurement. So what we need to do is make sure that we convert the 39 inches into feet. And of course, the building would not be measured in inches, right? So we want to make sure that we measure that in feet. So that's why I'm going to make everything into feet. We know that there are 12 inches in 1 foot. So if I take 39 and divide by 12, 12 goes into 39 3 times, and there's going to be 3 left over. So now I'm going to reduce that to 3 1/4. And in terms of a measurement in decimal form, that's going to be 3.25 feet. So I had to do that first before I even set up my proportion, and the proportion is going to help me find out how tall that building is. So I have a height of a stop sign or signpost, some kind of thing, and that's 5 feet. And then I have my shadow of that item. And then we don't know how tall the building is, but we do know that the shadow is 78 feet. Now everything has to be in feet so that when we get our answer, it will also be in that same unit of measure. So I'm going to cross multiply. And I end up with 5 times 78 equals 3.25x. 5 times 78 is 390. And when I go ahead and divide by 3.25 on both sides, x is going to equal 120 feet. So our building is 120 feet tall with a shadow that's 78 feet tall or long, and then our stop sign is 5 feet with a 3¼ foot shadow. So you're pretty familiar with these kind of problems because we've been doing them in class. And I would like you to finish up the practice problems number 5. You're going to assume in example 3, suppose that the building casts a shadow that is 52 feet long. And then that would give you an indication of how tall the building would be if you set up a proportion. Remember that shadow of the stop sign is 3.25 feet. So you're just changing the one number and recalculating. And then number 6 says you and your friend are standing next to one another outside. Your shadow is 23 inches long and your friend's is 24. And then assume that you are 5 feet 5 inches tall. It always helps to draw a diagram, so you don't have to draw a super fancy one, but draw one and then also show your work because you want to find out how tall your friend is based on the information given. And if you have any questions about any of the information in this video, make sure you ask questions, please. Thanks for watching.